work out nice for us that way, because the integration by parts table wouldn't work that way. Because what you put for dv, you wouldn't have anything to put for dv. This is a good question. Could you ever let u be dx? And then let dv be the sine of natural log x? This wouldn't make any sense because this has to include dx in it. To say that this is a derivative of something, it needs a dx here. Or else you won't be able to integrate it. So this can never be u. Yeah, okay, well, we need to choose something, right? If we're using integration by parts, are we using integration by parts? Okay, you don't have much other choice, do you? Well, you could try a basic u sub. Maybe we try a basic u sub. Let me try a basic u sub. The only thing that makes sense to me as a basic u sub would be natural log x. That's the only thing that makes any sense if I try a basic u sub. To me, the derivative of this is 1 over x dx, right? I don't have a 1 over x dx anywhere here, right? I don't have a 1 over x. I could try and be clever here and multiply both sides by x. But now I need to rewrite x in terms of u. So how do I get x here? I could do e on both sides. So e to the u equals e to the natural log gives you just x. So I could rewrite the left side as e to the u du equals dx. Do y'all see what I'm doing here? I'm trying to force a, what do they say, a square peg through a round hole here. I don't think it's going to work, but let me try and rewrite the integral. Sine of what's the natural log? I'm calling that u. And then what does dx become? Holy shit, this does work. E to the u du. It does work. Doesn't it? We just did this problem, right? We did this problem at the beginning of class, but we did it for sine of beta x e to the alpha x. So we have like a very general answer for this, don't we? So this could go with integration by parts at this point. I'm not going to do it that way, though. Yeah, it would work. You have to, this is the big thing, though. You have to see that, right? You have to know that right here, you don't have 1 over x, but if you multiply both sides by x, you need to turn x into something in terms of u. So you go back to this equation and solve for x. Using college algebra, you can get this. And then that's doable. Okay, but I'm going to try something else. I'm going to try sine natural log x here, and then this is just dx.
So if we started with the u sub, though, we have to remember at the very end to go and put that back.
That's right. If you did this u sub, hey, look, we did the problem a second ago, didn't we? Integral e to the alpha x sine beta x, right? What was the answer? Negative 1 over beta e to the alpha x sine, no, cosine
X over 1 plus alpha squared beta squared.
Okay.
Alpha over beta squared e to the alpha x sine beta x over 1 plus alpha squared beta squared. Plus c.
Okay. Plus c. All right, so for this problem right here, what's alpha and what's beta? What's the number in front of the variable here? 1. What's the number in front of the variable here? 1. So imagine that all the alphas and betas were 1s. Then can you tell me the answer to this? It'd be negative 1 over 1, right? So just negative e to the x, but for us it'll be e to the u. So just negative e to the u cosine of just x, which for us is u, right? So cosine u. What? We're doing this, but we're treating all the x's like u's here for the formula we have. All over what? What's this? 2. So I'm just going to put a half in front of this, minus a half. And then over here, 1 e to the u sine of u. It'll be plus. And then I'll have a 2 on the bottom as well. So e to the u sine of u. That's the antiderivative. Using the formula that we just came up with, that's the antiderivative of this.
Don't you also
Yeah.
have to plug in natural log of x?
Yeah, so now this is in terms of u, right? So that's what you were asking in the very beginning. It's like, okay, once we get this plus c, then we need to go back and replace u with this, right? So our final answer would be negative 1/2 e to the natural log x, right? Whoa, what? Cosine of natural log x plus 1/2 e to the natural log x sine of natural log x plus c, right? And then e to the natural log of x would just be x, and e to the natural log of x would just be x. All right, I'm going to just leave that there. I'm going to go back to this.
Yeah, is this the part where you wanted to be here for 6 hours?
I mean, this is fun, right? I mean, we're using what we got earlier, right? I mean, like, we went through all this suffering for this formula, right? And now we can use it on this. So I like that. All right, let's do this, though. I'm going to go back to this and just take a derivative. Chain rule, right? Derivative of that is cosine of natural log x times 1 over x dx. So I take derivative sine of something is cosine of it, derivative of what's inside, 1 over x dx. Antiderivative of dx, or antiderivative of 1, x. So this should equal ultraviolet is just x sine natural log x. Looking good, right? Isn't that x? Well, yeah, no, that doesn't look good. Sine, oh yeah, sine of natural log x. That's ultraviolet, okay, minus integral space. Any constants come out? No. Hey, do y'all see the 1 over x and the x? You see that those go away? So all you're left with is cosine of natural log x dx. Any ideas?
If you do it again.
Do it again. Do it again. If you do it again, see, we did it one time, right? We did it one time, and this became a new integral with cosine, right? If we do it again, we should get the sine of natural log of x to come next time. And then it will appear on the other side, and then we'll add it to both sides, and we'll be done, right? All right, so I'm going to go again. I'm going to let u be cosine natural log x, and then dv be dx. Yeah. Sorry, my natural logs look like w's. All right, so I'm just doing this right now, right? Just this over here. So du will be negative sine natural log x 1 over x dx, and this will be an x again, right? Voodoo is going to be nice. The x's are going to cancel. Then it's going to appear. So this is x sine natural log x minus ultraviolet x cosine natural log x minus integral, wait a minute, hold on, minus plus, okay, I almost messed this up. Do y'all see here to here, do y'all see that negative sign? That comes out, right? And that becomes right here a plus. That's important because I needed that negative to come through and make it a minus so I could add it on both sides. So if you miss that, that's a bad situation. Sine natural log fucking thing here, dx. Any mechanical engineering majors? Mechanical? Have y'all looked at this staircase on the outside of this building? Has anyone looked at it? On the outside, not the one not that big one that goes down, the one that kind of goes back and forth. Yes? You seen it? So have y'all noticed the way it's built? Yeah. Go look at it. It's really interesting. Yeah. I believe that it's okay, but I wouldn't stand on it with 30 people. Let's just put it that way.
Would march across it?
Yeah, go look at it. It's at the, at the end of this building. It's the one that goes back and forth down. Look at the, when you go down the stairs, it goes like this, right? It goes something like that. And at each end, there's like a landing. I'm doing a terrible picture. Anyway, just go look at it. There's very little structural support. Just go look. It bothers me. Why am I thinking about that right now? I don't even know why I'm thinking about that. Okay, let's just keep going. X sine natural log x. All right, let me distribute that minus through. Minus x cosine natural log x. And then minus integral sine natural log x dx. Okay? All I did here was distribute this minus sign through. And you see it appears now? The integral we're looking for appears on the right-hand side. Just to be thorough, I'm going to come back and write the original problem. I'm going to write it again. This is equal to, so far, sine natural log x minus x cosine natural log x, and then minus the integral of sine of natural log x dx. Add it to both sides, right? Add this integral here, add the same integral here. How many of them are we going to have? 2 of them, and then I'm not going to want that 2 there, right? So I'm going to divide everything by 2. So let me just give you a final answer here. It should be this first thing divided by 2, so 1/2 x sine natural log x, and then minus 1/2 x cosine natural log x, because I had to divide both sides by 2, and then plus some constant that I don't know. And I think that's what we had before, right? I erased it, but I think that's what we had down here. All right. So there was one problem that was requested, kind of. It is a good problem. I like it, these types of problems. Antiderivative of arc sine x dx. So everyone here should know what the derivative of that is, right? We did that in the very beginning of this class, right? We talked about derivatives of inverse trig functions. So we all know the derivative, right? We just don't know the antiderivative, and that's what we're looking for. So for this, integration by parts, you only have one choice for u, and that is arc sine x. That's your only choice. dv has to be dx then. Now, the good news is that the antiderivative of this, that's just x, so that's not a problem. The derivative of this, again, you have to know, because we did this. I proved it to you, in fact. It was 1 over the square root of 1 minus x squared dx. Ultraviolet, right? Ultraviolet is this. The new integral voodoo is this. I'm going to write it down. Initially, I'm like, crap, that new integral looks terrible, right? That's my initial reaction. It's like, this voodoo integral looks pretty intimidating. Initially, when I'm first thinking about it, right? So ultraviolet is x inverse sine x minus the integral. Any constants come out on voodoo? No constants, right? So when I do these together, when I take this and multiply it times x, really just an x appears on the top of that, right? That's all that happens. So I have x over square root of 1 minus x squared dx. And you might look at that and start like freaking out a little bit. Or, yes, just a basic u sub. It's just a basic u substitution. Do you see something and its derivative? What's the something? 1 minus x squared. And the derivative of that, negative 2x, right? So I'm going to look at this as being my u, right? Now, things are a little weird here, and you have to, people have different kind of philosophies on this. We've already used, excuse me, u over here, haven't we? Now, my new integral doesn't have u's in it, right? So if I want to, I can start calling something u again, if I want to. But if you want to be like safe with things, then maybe we don't call this u so you're not confusing it with that u. We don't want to use u twice if they mean two different things, right? Like here I'm saying u is this, but over here I'm saying u is this. Do you see what I mean? It's like maybe we should be safe and just call this something else, like maybe w or something. I don't know. Let's do that. I'm going to call this w. And now I'm making a w substitution instead of a u substitution. So what's w? What's the derivative of w? Negative 2x dx. Do we have that there? Almost, right? We have x dx. So we'll scale by negative a half, right? So negative a half dw equals x dx. And now I should be able to rewrite that integral. I'm going to do it right here. I'll take whatever I get and I'll put my answer back up here. But right now I'm doing all of this right here. So what's that new integral become? 1 over the square root of u. W, sorry. 1 over the square root of w. And what did the x dx become? Negative 1/2 dw. So I need a negative 1/2 dw here. Let's keep moving with this. Okay, that's the same as the antiderivative of w to the negative half power dw. I'm doing that because I'm going to use the power rule, right? Don't say that's natural log, right? The antiderivative, right? You have to use power rule. So negative 1/2 comes. Okay, add 1 to that, you get a half, right? And then reciprocal, so 2w to the 1/2 power plus c. These twos cancel. You just get negative square root of w, right? W is 1 minus x squared plus c. So this is, that means square root. W is 1 minus x squared. That's what this whole integral gets replaced with. So this becomes x inverse sine of x plus, because that has a minus on it, doesn't it? And this is a minus here. So this is going to become plus the square root of 1 minus x squared plus c. There it is. I went under.
Sir,
Yes.
if you raise 1 over the square root of w to the power 2, that whole thing, and then do the power 2 on the other side, could you then do natural log?
Power of 2 on the other side. What other side?
So power 2 is negative 1/2.
Is that what you're saying?
Yeah, but then you do it to the negative 1/2 on the outside.
Ah, okay, but okay, I see what you're saying. I'm glad you're asking. When you have an integral, right? When you have an integral and you have something inside of this, you can always multiply this by 1, okay, top and bottom by something, right? You can add and subtract something, so you could add 2, subtract 2. You cannot just square it, because if you square it, you would have to have an equation you're working with. To do something to both sides, you have to square, right? Both sides of the equation. You can't just arbitrarily square something, or you change what it is, right? If I say, what's 1/2, everyone understands what 1/2 is. If I now say what's 1/2 squared, it's no longer 1/2, right? So by squaring this and squaring this, there's no equals in here, right? So there's not and even if there was an equal, that's not a valid thing. So like if you call this y, right? If I wanted to square this, you square this, you're actually squaring the whole integral, not the argument of the integral. So just don't ever try and do that. Don't ever try and square the argument or cube it or take the square root. You can only multiply by 1 or see some sort of hidden 0 being added or subtracted. That okay? Good question, because students will sometimes do that. To make the problem easier, they're like, oh, I'll just square top and bottom. Can't do that. It's no longer 1 over the square root of w anymore. All right, there's one more that I want to definitely get to today. I want to let you sit here and look at it for a few minutes and see if you can figure out how to get through this one. All right, what time is it? Let's go like 6, 7 minutes. You can talk to each other. I would like you to talk to each other. See if you can figure out how to get through this one. Yeah, don't use it though. Don't reference it. See if you can. How do you win the lottery? And buy a ticket, right? You have to play, right? Same with this. You got to play. You got to put something down and start, go, right? Whether it be if you want to do integration by parts, do it. If you want to do U sub, do it. But do something. No matter what, do something, right? Did everybody get their tests? Yes?
I know how to write print.
Your homework for this section is on the schedule, okay? And I do mean this is a very important section for you. Try every problem 1 through 32. Evens and odds. You mean get down there, get dirty, spend your weekend doing it. Yes? Yeah, you don't need to redo them. Yeah, 1 through 7 was the assignment from last time. Now you just continue 8 through 32. All right.
You don't have to do 1 through 7.
No, you have to redo them. No. Would it hurt you to redo them? No. But you don't need to. Yeah? Gotta try something. Take a swing. Take another swing. You get to, the good thing about this is not like baseball. You can swing as many times as you want. It's not 3 strikes, you're out. On the exam, you get 1 swing.
And then you know the derivatives, so we know the antiderivative.
I'll admit this is a tricky problem. I'll admit that, but it'll go. We'll go a couple more, just maybe like 2 more minutes, see if anyone gets anywhere with it.
Yeah, but then you gotta do another integration by part.
This is a homework problem. This is in the textbook. I'm going to help you get started, but I'm not going to do it. That's the way to go, right there.
The only way?
It may not be the only way, but this is, I think, the cleanest way. If you let u be the top, right, when you take the derivative, you're going to have to use what? Product rule, right? Now, the antiderivative of this, be careful, it's not arctan.
Yeah.
Do a basic u sub to go from here up. It's just a basic u sub to go from here up to here. All right? And then once you do that, there's still some little hidden magic in there, but it'll work. All right? All right, everyone, have a good weekend. Y'all can stay and work on it. I don't care what you do, but we have 5 more minutes. We don't have enough time to get into the next material. Yeah? Do your homework. Y'all have a good weekend. Unless y'all want to do a quiz. No, we can stay and do a quiz.